Let's talk about PubSub, which is an enterprise messaging transport system available on the Google Cloud platform. And as always, here is a question that I'd like you to think about. When a data set is unbounded, what constitutes the source of truth? Now, if you have a bounded data set like a file or a database, the source of truth is all of the data in that file or database. But if our data set is unbounded like a stream, what then is the source of truth? Let's keep this question in mind as we talk about PubSub. PubSub is one of the services available on the Google Cloud platform, and it can be defined as messaging middleware. It can be defined as an enterprise level message transport system which takes data from many senders and relays it to many receivers asynchronously. In this way, it helps to decouple senders and receivers in a very robust way. The name PubSub comes from the terms publisher and subscriber, and indeed, these terms are central to the architecture of PubSub. Publisher apps will create and send messages on a distinct entity known as a topic. There are also subscriber apps, these are the subs. Subscriber apps subscribe to topics and will then receive all messages which belong to that topic. And each subscription can be thought of as a message queue or a message stream which takes messages to a subscriber. A message itself consists of data as well as some attributes. Those attributes can be set by the publisher. It, of course, includes a topic. The message attributes are key value pairs that the publisher chooses to include with the message. So, at a high level, that's what's going on in PubSub. Publisher apps create and send messages to a topic. Subscriber apps subscribe to a topic. They will then receive all messages on that topic. Once a message has been acknowledged by a subscriber, it will be deleted from the corresponding queue. Now, we've discussed the importance of the queue being persistent, and that's why messages need to be persisted in that message store until they've been either delivered or acknowledged. There is one queue per subscription. In effect, for each subscription, the queue or the message transport is the source of truth. Subscribers could either be push or pull subscribers. If they are push subscribers, they will use webhook endpoints in order to get the data delivered to them. Pull subscribers will fetch the data for themselves by connecting to an HTTPS endpoint. PubSub has a number of interesting use cases. A lot of these are listed in the Google Docs, and it makes sense to understand them. Consider, for instance, the case of balancing workloads in network clusters. Here we can have a large queue of tasks distributed over a set of workers, such as Google Compute Engine instances, for example. Or take something like an order processing application. Here, asynchronous workflows are required because the orders need to be processed by workers which are separated or buffered in some way from those orders. Or consider something like sign up notifications. Maybe you've noticed that when you sign into your Gmail account, you get updates into a bunch of email accounts which are connected to that Gmail as the backup. What's happening here is there is a service which accepts the user signups and then distributes those notifications to a set of downstream devices or accounts which wish to receive notifications about those signups. Another use case can be the refreshing of distributed caches. So, let's say an application pushes invalidation events. These will update the IDs of all objects in any of the distributed caches that have been changed. Another use case might be logging to multiple systems. Let's say you have a Google Compute Engine instance which is writing logs to a monitoring system like Stackdriver monitoring, to a database or a data warehouse like BigQuery, and so on. Streaming data from a large sensor network is another prototypical use case for PubSub. You might have sensors which then stream data about temperature or fuel or whatever else it is. These are processed and then, in some sense, analyzed by backend servers which are hosted in the cloud. Let's now trace a message through its entire life cycle that will give us a good idea of the architecture of PubSub. It all begins when a publisher creates a topic in the PubSub service and sends a message to it. The message body is called the payload. The message could also include attributes that have been set by the publisher. Those messages will then be persisted in a message store until they are delivered to the subscribers and acknowledgements are received. This happens via a subscription. A subscription is what receives messages. So when the PubSub service persist messages, it will forward messages from a topic to all of its subscriptions individually. Recall that there are two types of subscriptions, push and pull. In push subscriptions, PubSub will send the subscription to the subscriber. In a pull subscription, the subscriber will fetch the data by accessing an HTTPS endpoint. One way or the other, the message finds its way to the subscriber. The subscriber gets those pending messages from the subscription and then acknowledges each one to the PubSub service. Once that message has been acknowledged by the subscriber, it will be removed from the permanent storage. This architecture revolves around a couple of planes. There is a data plane which involves moving messages between publishers and subscribers, and a control plane which involves the assignment of publishers and subscribers to different servers on the data plane. The servers in the data plane are called forwarders, and those in the control plane are called routers. A publisher is any application that can make HTTPS requests to googleapis.com. So, this includes App Engine apps, Compute Engine instances, apps running on any third party network, in fact, any mobile or desktop app, or even a browser. Subscribers can be either push or pull subscribers. Push subscribers are exactly like publishers, any app that can make HTTPS requests to that googleapis.com URL. Pull subscribers are a little different. These must be webhook endpoints which can accept post requests over HTTPS. The post requests are required because, after all, the data is going to be sent to these subscribers by the PubSub service. Let's now tie this conversation about PubSub back to our discussion of a stream first architecture. We had discussed how in traditional systems which rely on files or databases for batch processing, there is a clear source of truth. The data is whatever data resides in the file or in the database. There's very little ambiguity. But as soon as we transition to a stream first architecture, the data now might come in from a stream or from a traditional system. It will then need to be aggregated or decoupled from the senders and the receivers using some kind of middleware. That middleware will in turn pipe it into a stream processing application. And that middleware is going to collect all of the data from all of these disparate sources into a message transport layer. That message transport or that queue has a bunch of important properties, and indeed, PubSub is exactly this. PubSub plays the role of message transport. It lines up all of the events, all of the data items nicely and sends them into a data processing layer. This is the stream processing application, which could be in Dataflow or BigQuery or anything else. In this use case, the stream is the source of truth because, as we saw, data is persisted in the stream until it has been acknowledged by the receivers or the subscribers. So, to answer the question that we had posed at the start of this video, when a dataset is unbounded, the source of truth is usually just the stream or the message transport layer, which buffers the senders from the receivers.